The logarithms are a strange kind of definition of functions, aren't they? It's the inverse of exponentials. And as such, there are equivalent statements between exponential and logarithmic and stuff. Also, because they are kind of backwards designed, so to speak, as the inverse of exponentials, they actually have some rather odd algebraic properties as well. Okay, so that's what this section is about, is to be exposed to these interesting and very useful properties of logarithms. We use them all the time in calculus, solving differential equations. We use properties of power rules, which you guys know, and now you guys are going to know properties of logarithms as well. Okay, I personally break them up into two pieces, but this is going to be one video. One is going to be the simple log properties, okay? And I wrote them out. Log of 1 is always equal to 0. Hey, we saw that, a hint of that last video. And log of the base always equals 1. Okay, and I have those written down here. And then we get into the three biggies later on in this video, okay? So it says log base a of 1 is always 0. Why? What you should do, let's write it in exponential form. Let's see if it's true. A to the 0 is 1. Let's write it. A to the 0 is 1. Do you agree with that? You do? Great. It's true. So if I wrote here, for example, I go, what about log base 17 of 1? What's that equal to? Guess what? It's equal to 0 because 17 to the 0 is equal to 1. It doesn't matter what base you put there. Okay. This helps us solve things, by the way. It could be something like, I don't know, log base 2 of x is equal to 0. Well, what the heck is that? Well, x has to be 1 because 2 to the 0 is equal to x. And actually, I'm getting ahead of myself. This is the next section. But then you realize, oh, 2 to the 0 is 1, so x has to be 1, and you're done. Okay. The other one, and it actually kind of extends as well, and I think I will extend it in this video. It says log base a of a is 1. Really? Why? Let's see. Well, if I do the exponential form, equivalent exponential form, it says a to the 1 is a. Hooray! It's true. It's true. Doesn't matter who you are. So I could write log base 21 of 21 is 1 because 21 to the 1 is 21. But I'm going to extend it a little. I can say something like this too. What about log base a of, say, a squared? What's that equal to? Remember we put the big X there or something? Well, what's that equal to? Watch. A to x, a to the x equals a to the 2. What's x? It has to be 2. So in other words, if I did another one, let's say I did log base 4 of, say, 4 to the 5th power. Well, if you put an x over there, it would be 4 to the x equals 4 to the 5. What happens really is the log base 4 and the exponential 4 cancel, and it spits out that 5. And that's what happened here too. Spits out that 2. It's equal to 2. Okay, so going beyond that, if you have, in other words, if I have log base a of a to some power m, it's always equal to that power because the log gives you the power of the base that reaches that number inside. Okay, so this is another one you can add for free. And you can think of it again, if you get really up on this, as the log and the base cancel each other out. Pretty cool. Now, let's talk about the three biggies. Here they are. There's the log of a product. Okay, now if you've never seen this before, you got to slow down here. It says, okay, and I quote, log base a of m times n is equal to log base a of m plus log base a of n. So the log of a product is equal to the sum of the logs. So if you see a multiply inside a logarithm, you can split it apart as a sum. And over here, I wrote this out. I had fun figuring this out. I just go, well, watch the logic here. Log base 3 of 3 to the 5, we saw that previously. Remember this guy right up here? Log base a of a to the power. Log base 3 of 3 to the 5 is 5. Plus log base 3 of 3 to the 2 is 2. Add them together, you get 7. 5 plus 2 is 7. Yay! But then that's the same thing as log base 3 of 7, which is equal to log base 3 of these two multiplied, and we've done it. Okay, look at this side and look at this side. Log base 3 of a product is equal to the sum of the logarithms on the left-hand side. Kind of funny, kind of weird. That's how I did it anyway. So you could have something as an example. You could say, well, log base 2 of 3 times x can be written as log base 2 of 3 plus log base 2 of x, because it's a product. Anytime you want, you can split it apart like that. Or you can put them together. You could have like log base 3 of, say, x plus log base 3 of, say, x plus 1. The sum becomes inside the logarithm log base 3 of these two guys multiplied. I would write it as x times x plus 1 maybe. And you can see you can tear it apart. You can also build it together. You can split apart a logarithm, you can put it back together, and that's what the exercises are about on the next page. And in section 4, that's the big part. That's the thing about section 4. Okay, let's go to the other two. This one says the log of a quotient is equal to the difference of the logs. What? Look, if I have a quotient, that is, if I have division inside there, then you can, if you want, write it as the log of the numerator minus the log of the denominator. Anytime you want. And then here we go with another explanation if you want to read it. I have log base 5 minus log base 3. Log base 3 of 3 to the 5th minus log base 3 of 3 squared is 5 minus 2 is 3. But that's the same as log base 3 of 3 to the 3, which is the same as log base 3 of 3 to the 5 divided by 3 to the 2. Remember, you go 3 to the top power minus the bottom power is 3 to the 3. So what I'm doing is I'm getting a feel for logarithms or powers. When I divide, I subtract the powers. When I multiply up here, I add the powers. That's what's happening. They're mimicking the power rules, really. Okay, so you could have an example. You could say something like, well, I'm looking at log base 7 of 2 divided by x can be rewritten, if I want to, as log base 7 of what? 2. Minus what? Log base 7 of what? X. Yep. It can split apart, and you know what I'm going to do. You can put them together again, too. You can say, hey, man, I got this thing broke apart. What I have is, in fact, I'll have some fun with this. Watch. Log base 5 of 2 plus log base 5 of A minus log base 5 of B. What in the world? Watch. These two are like the above example. What happens there is they can go together, and you can write it's log base 5 of 2 times A. And you still have minus log base 5 of B. Well, that one is a division, isn't it? So we make it a big logarithm, log base 5 of what? 2A divided by B. And there you go. We built up a logarithm from broken up logarithms, so the pieces of logarithms. So we have two properties so far. Multiply becomes add the logs. Divide inside a log becomes subtract the logs. And the last one is a power inside a logarithm. Okay, the log of a power. The log of a power equals the power times the log. And again, I have it kind of explained here. I go 2 times log base 3 of 3 to the 5 is equal to 2 times 5, which is 10. But that's the same thing as log base 3 of 3 to the 10. But 3 to the 10 I write as log base 3 of 3 to the 5 to the 2 power. Where you remember 3 to the 5 squared is really 3 to the 5 times 2 is 3 to the 10. Okay, so this power inside here can pop out, and you can see it over here. You see that? So this is where the power pops out. This is one of the more useful ones. This power, if you have a power inside, can come out as a factor. So I write the power comes out and multiplies with the log. And once again, you have something like, all right, so log base 8 of 3 to the 4th power can be written as, according to this final property, he could just pop out front 4 times log base 8 of 3. Now people have trouble and you want to really stare at that. All I'm doing is moving the 4 out. Anytime you want to do that, you can. Go the other way. Let's say I have 1/2 log base 2 of 5. What do you think I'm going to do now? I'm going to go the other way. I'm going to bring him in if I want to. And I've got this is equal to log base 2 of 5 to the 1/2 power. And if I want, I can write, that's really log base 2 of the square root of 5. Whoa. Whoa, 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 whoa. I know. So pause it. Pause it and look at that. A couple of examples of that. Okay. So up and down the street here, we've got applications of these rules. Okay. Pretty cool stuff. Okay, so let's drink those guys in. I remember doing this where we had some strange thing in calculus, e to the, 2 natural log of x, and they're going, what do I do? What do I do? This is what we did in calculus. Take the 2, bring it in, you get e to the natural log of x squared, and then we realize, this is another property we studied, the exponential and the log cancel, and you get x squared. This is a calculus move, but man, I'm telling you, the properties we're using and learning now, we use in calculus. Okay, so of course that's not going to be on your test, because this is Algebra 2. We're working our way there. So the rest of this video is basically doing homework problems. I have 4 of them here. No, I have more than that. I have 7 of them, but they go quickly. Okay, so it says, use log properties to expand a log expression. I took the wording from the book. Okay, what they want us to do is look at this and break it. In other words, to expand means break up into baby logarithms, if you will. Break up expression into the sum and difference of logs, okay? And so that's a lot of verbiage to see what I mean. One example will do it. Okay, what I have here in this first one is I've got a product. See it? These two multiplied together. So what we can do is write log base 2 of one of the factors plus log base 2 of the other factor. So x here and x plus 2 here, and you're done. That's it. They just want you to get used to the properties of logarithms. That's it. Okay. The next one. What I see in the next one is, do you see what I see? Do you see what I see? What we have is a quotient. Or we have divide, don't we? So we can write this as log base 4 of something, and then what else? Yep, minus log base 4 of something else. And the numerator goes up front, the denominator, 3x minus 4. Now watch out. We're done, except for people might ask a question, can you split up the 3 from the x? And that's a good observation. We did something very similar to that, didn't we? Up here, very first example, this guy, right there. But notice he's just 3x by himself, so he can split apart. That leads us to a discussion that says, hey, listen, if you've got a sum or a difference, there's no property for that. There's no property. Some people do this, and therefore log base 4 of x plus 5 is equal to log base 4 of x plus log base 4 of 5. You see where they're coming from, right? You know what I'm going to do? This. That's not true. If you have a sum or a difference, they just have to stay there. And the way you can explain it is to go all the way back up to these statements, why these properties are true. And if you put a plus or a minus in there, that doesn't work. Okay, so that's a good question, but no, because of this minus 4, we're stuck. Okay, we're stuck. And that's as far as you can take it. Try a couple more on your own. Oh, they get nastier. Maybe you'll need my help. I don't know. Yeah, look at this one. It gets more challenging as you go down the page. So what I'm going to do is I'm going to rewrite this to help us out. You see that cube root? That's what it's supposed to be, as a third root right there. It doesn't show very well in the type, does it? Well, what is the third root really as a power? It's the 1/3 power. What can we do with powers? And what I used to do is I used to number these guys 1, 2, and 3. So the product rule would be like, oh, I used this would be on the board, oh, property 1, this was property 2. Down here with the power, that was property 3. We're going to use the property 3 and bring him out. So we would write 1/3 times log base 5 of these guys. This is really an elaborate one. Okay. Are we done? Not really. What we have to do is split that division up next. So that would be like property 2 with the division. Now watch what happens. The 1/3 is taken care of. Now I'm going to put a big old bracket here and I'm going to split that thing up. We're going to say log base 5 of minus log base 5 of, and the numerator goes here. You following? And the denominator here. So I took a power out. That was a surprise, wasn't it? Oh, a radical comes out. Well, we've seen radicals before. One of the problems up here, here it is right here. The 1/2 goes in as a radical, but this time I took the radical out because I'm breaking things apart. Okay, that's what's happening here. Are we done? What else do you see? I see it too. Let's bring that power. Do I have to go all the way? Yeah, you do. So I would write an answer looks like this. 1/3 times log base 5 of b minus 3 minus, out pops the 2, log base 5 of b. That's cool. The only other thing you might think to do is distribute the 1/3. Don't have to do it. This is good. This one I think I'll give to you to mess around with. Try this one. Okay. Which property? How about 2? And down here, by the way, that was property 3 again. Okay. So it went 3, 2, and 3. This one's going to go, I think it's going to be property 2. So it's equal to log base 3 of minus log base 3 of, right? And the numerator goes here. The denominator goes here. That's a to the 4, and then b, cube root of b. Well, obviously, or is it obvious, the denominator is not broken up enough. But we're done with the numerator because it's a minus, so we're stuck with that. Log base 3 of a minus 6. By the way, once you get good at these, you can do these as one-liners. I'll show you on this one in a moment. Okay. But now we're going to use property 1, which is a product. So now this is, you got to be careful with your sign. Minus whatever happens, happens. And what happens is this. Log base 3 of a to the 4 minus, oops, I didn't do that. I got to do color. Let's do color. Log base 3 of something minus log base 3 of something else. And those somethings are the numerator. No. It's a plus. There's no numerator. Those somethings are the factors. A to the 4 and the cube root of b. Now we've seen the cube root of b also, haven't we? That's the 1/3 power. Why don't I do that now? Because that's going to be our last step. It's b to the 1/3 power. Okay, so we're going to now, we use property 2, we use property 1. Now we're going to use property 3, which is these powers are going to bug out of there, man. Okay, so we've got log base 3 of a minus 6 minus bracket 4 times log base 3 of a plus 1/3 times log base 3 of b. And that's all she wrote, man. You can distribute the negative if you want. But here's how I would do this super fast. Let me write it again. Log base 3 of a minus 6 over a to the 4th cube root of b. As a one-liner, this is what I do. I go, okay, the numerator goes first. I go log base 3 of a minus 6. Anything from the denominator is minus, so minus the next guy. If there's a power, pop it out. 4 log base 3 of a. The cube root of b is from downstairs, so minus. The power is 1/3 log base 3 of b. Okay, super fast. And these, of course, are identical. They're equivalent statements. All right. Those are a couple of tougher problems of breaking things apart. Okay, it's a longish video because we're going to wrap it up with putting things together like Frankenstein Laboratory, and then we'll be done with section 4. This is how the homework goes, playing around with the properties. Okay, now they say write each log expression as a single logarithm. Build it together again. So you got to remember your properties. Subtract is really the division property. So we'd say this is equal to log base. Now here's the thing, people. I have log 2, log 2. All of a sudden there's only one log 2 because it's the property. It says log base a of, like, say, m over n is the same as log base a of m minus log base a of n. So we're going that direction. We want to take these two and make one. See how it has 2 logs here and then there's 1 here? We're going in that direction. So with the minus, we're going to go, the first number is 15 divided by the x minus 5. We're done. That's it. Yeah, it's an easy early one, right? The next one, it's a little more elaborate. If you compare it to stuff we did where we were breaking things apart, suddenly we see these little numbers that are out in front of our logarithms. And those numbers, what do they mean? Oh, powers. So yeah, the first thing I would do on this one is property 3, move the powers in. I'd say take this 1/2, put it in as a power, take the 3, put it in as a power, and so we do. We go, this is equal to log base 4 of x to the 1/2 power. Never mind the plus for now, plus log base 4 of x plus 1 to the 3rd power. Awesome. All right, now you have the plus to deal with. That's property 1 where it becomes multiply. So it becomes one big happy logarithm, x to the 1/2 times x plus 1 to the 3, or you could say, if you want, log base 4 square root of x times x plus 1 to the 3. Looks good. Good stuff. I only have one more, okay, and our video is done. So go ahead and rewind and look at it and ask about it and ask me in class. So our ticket out of here is this one. I think we're going to be using property 3 again, where the powers, all of them, will go in. But notice the minuses. What do you want to do with the minuses? Let me show you how I do this all at once if you want to brave it. I simply go, it's going to be one logarithm, base 4 in this case. Anything that's positive goes upstairs. Anything that's negative goes downstairs as products. Now be careful. When you put it all together, it's either divide or multiply only. When it breaks apart outside, it becomes pluses and minuses, okay? So the numerator, watch, it's going to be property 3. It's going to be property, let's say, 2 as well with the division. But what I'm going to do is I'm going to bring the 3 in as a power and bring the b over as well. B to the 3. See how it says log base 4 of b to the 3? I put it in, log base 4, and it looks like this. So it's log base 4 of b to the 3. But I'm in a hurry, and I want to put the 2 negatives downstairs as well. So if I'm in a hurry, what I do is I go, oh, it's a to the 3 downstairs, because it's a negative 3 power maybe. Think of it that way. Negative power puts it downstairs. Another negative power. How about I write cube root of c there? This is the answer right there. I can do it in one fell swoop by just knowing what I'm doing. And I think that a lot of you will be able to do this as well. But we should maybe, most of us, be careful. So What are the mechanics step by step? Well, the first step I do is put the powers in. So tuck the 3 in, third power. Now here's the tricky part. You can leave, I think the most straightforward way is just bring the 3 in without the minus and bring the 1/3 in without the minus as well. So what we could write is minus log base 4 of a to the 3 minus log base 4 of c to the 1/3 power. Okay. Now, if you do go step by step, it is laborious and it leads to some mistakes, but what people tend to do is they do this. Well, I know when I subtract, it becomes division. So they do pretty well and they go, okay, so I've got log base 4 of b to the 3 over these a to the 3, okay, but then I still have this minus log base 4 of c to the 1/3 power. Okay. All right. So then they go, okay, here we go again with, that was property 2. Here comes property 2 again. And I get answers that look like this, and I say more power to you. They do b to the 3 over a to the 3, and you know what? Over c to the 1/3 power, which is like, whoa, watch out, it's going to fall over. You got divide, right? Are these the same? The answer is they are. If you were to look at this and go, well, okay, that's like c over 1, and if I invert and multiply, right? If you do one more step, it looks good. It's b to the 3 over a to the 3 times 1 over c to the 1/3, so tuck in that 1/3 power there, and you're done. All right. I think that's it for this section. Enjoy the homework there. It's pretty straightforward stuff. You just have to practice it, and my math lab will help you out. Okay, see you at the next one.